Good. So we started the recording. In our last class, we did talk about how should we how do we perceive the curvature in terms of the power of y and power of x. So what does that mean? So today I want to start with how do we deal with gradient? How do we calculate the gradient for any line? Let me show you a simple procedure for this. Let's say we want to measure the gradient or slope value for a certain line. How do we do that? So let's say these are x-axis and y-axis. We have a straight line that looks like, let's say, this. So let's say we want to measure the gradient of this line. On the simple way, if you ever have access to a given straight line, in many of the cases this shows up in your paper 2 questions, you are expected to draw a triangle on your graph. I mean, you can calculate the gradient without drawing the triangle, because in our last class, as we have seen, that if we know the coordinate of 2 different points, let's say if we know the coordinate of 2 different points, you can essentially go for x2 minus y2 minus y1 divided by x2 minus x1 for your equation. Also, what we wrote in the last class, I'm going to rewrite it again. M equals to y2 minus y1 divided by x2 minus x1. That can be one equation, or vice versa. I can also flip it. Y2 y1 minus y2 divided by x1 minus x2. I can also do that. So mathematically, it's possible to calculate the gradient by only the coordinate values if you want. আরিফ, তোমার কি ভলিউমের সমস্যা হচ্ছে?
জি স্যার, একটু জোরে কথা বলুন।
I'm pretty much talking the regular voice that I usually talk through.
শুনতে না পারলে কি করা আছে আমার? আমার কাছে একটু আস্তে লাগতেছে।
Are you using any tab or in computer?
I'm using computer and I've also maxed out my
আচ্ছা, ঠিক আছে, আমি তোমাকে একটা সিম্পল জিনিস দেখাইতেছি, এটা করলে তোমার ভলিউম বাড়বে। হ্যাভ এ লুক। If you go আগে দেখো তারপর করো। If you go into your speakers, do you see it? Okay, if you right click on the speaker icon and if you open volume mixer, no, not volume mixer, ভুল বলছি, কোনটা দিয়ে জানি করে, হ্যাঁ, open sound settings, and then your speakers should be found here. And if you go in the device properties, additional device properties, okay, if you go here, have a look. If you go in the enhancement button, have this one clicked. Loudness equalization should be clicked on, and then apply and okay, and then get out of it. It will give you a sound boost. Check this out.
জি স্যার।
করতে পারছো?
Yes sir.
ভলিউম বাড়ছে?
হ্যাঁ স্যার, বাড়ছে।
Okay, that should help. So getting back to the whole point, Tasmia Fariha, তুমি জিজ্ঞেস করছো what is the topic today? You'll be seeing it. We are continuing the lecture on the graph from where we left off last class. So the gradient can be calculated by these two, either of these two equations if you know the two coordinates on the straight line. মামুন, আমি ভাত পরে খাবো, এখন ক্ষুধা লাগে নাই, ঠিক আছে? মামুন, ভাত পরে খাবো, আমি ভাত পরে খাবো, এখন ক্ষুধা লাগে নাই, হ্যাঁ ঠিক আছে। So this is something that you can do. Apart from, but in your physics courses, the examiners highly appreciate that you draw a triangle using the corners of the coordinate that you're going to use. So I always recommend the students to do that. There are multiple properties of the triangle that you're going to do. First property is that the amount of length of the triangle that you have compared to the length, the amount of length of the straight line that you have or you have drawn in cases that you are doing a lab experiment or something like that, your triangle should be quite large. Quite large, I'm using that term, it's a vague term, but in terms of measurement, the hypotenuse of your right angle triangle from which you are going to measure your gradient should be more than half of this line. So let's say I might as well try to draw a pretty big right angle triangle like this, but there is a logic for how this line should look like. There's a logic how this line should look like. এই পয়েন্টগুলো আমরা কিভাবে চুজ করব, how are we going to choose this line? There is a specific process for that, but the main important bit that the CIE examiners will look for, whether this much length is more than half compared to this much length. This is supposed to happen. Now, if you wonder how can I mean your chosen length for the hypotenuse of the right angle triangle to measure your, I mean, if you draw the right angle triangle, essentially this much is delta y. This is the y-axis variation, and this much is your delta x. So you can very well go ahead and calculate your delta y by delta x, and you can get your gradient. For lines like this, your m will be positive, and for lines like this, your m will be negative. Okay, this is something that we discussed in the last class. But the length of the hypotenuse that you draw for your right angle triangle to label delta y and delta x, that hypotenuse should be more than half of the available line. That's what I'm saying. So if this is x, this one should be bigger than x by 2. That's what I mean. Not, I shouldn't have given x. I should have given, let's say, if this is hypotenuse h and a height whatever. Are you getting my point?
Yes,
The difference, the distance between the two of these coordinates should be more than half compared to the available line of this thing. Okay, that is one part that the examiners really want, and you should preferably always draw the triangle. তোমার question নিচ্ছি, একটু wait করো. Additional to that, there is one more logic for how are we going to choose these corner points. The choice of this corner point is also a pretty important thing. So I'm going to show you a simple example for how this can be done. For that, I'll need a full grid. So I'll just copy a graph from someplace. Wait. Graph আছে হচ্ছে পেপার 4 এ। এত পিচ্ছি গ্রাফ আচ্ছা কাজ হবে। I can work with it. All right. Reem, you had a question. Bolo. Unmute yourself and ask the question.
Sorry, I didn't get the part where you talked about the hypotenuse.
This is a right angle triangle. So this line is supposed to be aligned with one of these vertical grid lines. This line is supposed to be aligned with one of those horizontal grid lines. And you can choose these 2 points. These 2 points will not be labeled to you. You'll be only provided with this red line, and you would have to do the calculation. So the choice of these 2 points is at your hands. You should choose such points so that the length of this whole thing is more than half of the available line length.
I still didn't understand. The length of what?
I mean, if I give you another triangle, maybe you can compare. Your triangle should not be this much. Because this is too much small. This is less than half. I can visibly see that this part is less than half compared to the whole red line.
Right.
This is not acceptable. The green one is acceptable. Does it make
Because
sense now?
more than half, right?
Yeah, exactly. The hypotenuse of your drawn triangle should be more than half compared to the available line that you have.
So I didn't understand.
কি বুঝো নাই বলো?
The green line thing.
The right angle triangle that you are expected to draw to measure your triangle, that hypotenuse should be more than half of this much length. If this much length is 200 unit, the hypotenuse should be more than 100 unit.
So sir, where this line will be given to us?
That's what I've been telling. The red line is already given to us from the very beginning of the lecture.
Okay.
All right. Keep up, everyone, please. Let me show you an example how to choose. The point that I'm trying to explain over here is that how can we choose these points? I mean, what is the tactics to choose these points properly? Let me show you a simple straight line over here, and we'll pick it up from there. So I'll use red for this line. This is the straight line that we are given in our question. and we are asked to find out the gradient of the straight line. So this straight line is at this state. Now, one of the important bit to draw the right angle triangle is that you should preferably choose points which has a perfect crossing with any of your grid positions. Let me elaborate what I mean. Let's say I want to draw a straight line of about this much size, a pretty large triangle I want to draw. So from the very right corner, I'm gonna start and to try and see that which of these lines, at which point do I have a good crossing. Let me explain what do I mean by good crossing. Have a look. You can see that this point right here, this point where my cursor is, the straight line is passing through the perfect crossing of two of these grid lines. Do you see that? Here. So what I mean is that these two are your grid lines, and your drawn line is actually getting through this through this corner properly. You can see that it's not left or right, but for this point, for this point right over here, let me use a different color. For this point, this is not the case. This is cutting through one of the box lines halfway. Can you distinguish these two properties? This is a perfect cross point between two grid lines. This is not. Similarly, this can be hypothetically said to be perfect cross point because you cannot essentially see a triangle over here, but we would never say this is a good cross point because you can see this is cutting it halfway. This is also cutting it halfway. So the idea is that whenever you will be choosing your points on your line, you should be careful to choose points like these. This is recommended, so that you don't have any difficulty reading of the coordinate. For example, whenever all of your grid values will be known to you from the scale that will be labeled on your graph on the axis and on the y-axis. So if you choose a point that has a perfect crossing like this, it will be easier for you to go ahead and calculate the length of the triangle. So in my opinion, if I go for multiple options, let's say I can choose this point for one of the vertices of my right angle triangle, or I can go ahead and choose this point. This can also work. I'm giving small lines over here just to make my decision. I can go ahead and choose maybe this one can also do my work. So to be honest, in a straight line, you'll find quite a good number of points. If you don't find any point that perfectly fits your requirement, you can go for some approximate points. Let's say I'm going to label those approximate points by pink. Maybe you can also use this one. If you don't find good cross points like these on the very, very farthest corner, you can use this kind of points where you have slight bit of movement. Or for example, have a look at this one. Have a look at this one. This is not perfectly having a cross. You can see it very well that is slightly above. But if you don't have any of those perfect cross points, you can use these points as well. Now, if you wonder why is this important, it is important because if you don't choose your coordinate point to be perfectly, which goes to the cross point of two grid lines, your measurement, your calculation value of this m will be slightly off from the value that the examiners are looking for. Now, this is very important because typically whenever the kids have to actually calculate the gradient out of a given straight line from a graph in their actual question, there is always a range of answers. For example, let's say this is the straight line that is printed in your question paper, and you are asked to calculate the gradient over here. And the examiner, let's say this gradient is supposed to be, let's say 23.2. That's too big. So let's say the gradient of this line is supposed to be, let's say 0.9572. It goes on like that. Let's say this is supposed to be the exact number that the examiners came up with. So what they're gonna do, give you about 10% margin so that you are covered for your errors. 10% মানে হচ্ছে 10% of 0.95 is about how much? 0.095, right? Think about this in your head. 10% of 0.95 is how much? About 0.095. So this is the typical range that the mark schemes work, but this is not a hard and fast value. What I'm trying to mean you is that in the mark scheme or in the actual instruction paper for copy checking, the acceptable value should be somewhat smaller and up to a somewhat bigger. Can someone do the subtraction and tell me this number? If I subtract 0.09 from here, I should get what? 0.8672 all the way up to how much? 1 point 0.0472. So you see, I have used the range lowest and the possible highest value by adding and subtracting this much one. This is a typical range that the examiners work by. Sometimes that range can be somewhat smaller. What this value means in the mark scheme, it would be mentioned that the gradient is acceptable, or the students will get full marks for the gradient calculation if the gradient value falls within anywhere within this range. So typically there is a good amount of range for your error thing, but you should know how to draw the perfect gradient, how to choose the points perfectly. So let's say for this graph, I'm going to be using this one. I'm getting back to green. So I'll be using this point over here, and over here, let's say on the far left side, let's choose another point which we can work with. Let's say this one seems like a good choice. This one seems like a very good choice to me. This one, I mean this one. Do you see it? It's a pretty good cross point. So I can now complete my triangle and go ahead. So the triangle shouldn't be too big. Acha, I need to zoom out. What should I zoom out now? This is the line. Okay. My triangle needs to be up to this much long. So that's one straight line. And then you draw the other one. That's the other straight line. So that's how your drawing might as well look like. Did I mess it up? I think I messed it up. I wanted to draw it from here. আচ্ছা সমস্যা নাই, এখান থেকে একলো হবে। মেইন জিনিস হচ্ছে তোমার the main part is that your preferred hypotenuse should be more than half compared to the line that is compared to the given line. Now if you wonder how can we calculate this is more than half, I mean this is a diagonal line, how could we possibly measure this length? Well, you can use your ruler. You can always use your ruler because this is a diagonal line. It's difficult to calculate this in terms of the division number. So you can use your ruler to measure how long is this red line from the very left to the very right end, and then measure the from you for your 2 points. And you can just check it out by doing simple math, that is your chosen line more than half or not. That's one way that works and easy to understand for everyone, because we are trying to measure length, we are trying to compare length, so we use ruler. Or there is another simplified way. If you don't want to use a ruler, or if you don't have access to a ruler, there's one more thing that is that as well. Have a look. The second way that I'm telling you is not essential that you learn this, but this is just something that I want you to understand, because this is just part of the knowledge base. That is, if you have a look, I mean, if this line has to be more than half, the coordinates of these 2 points should be covering, I mean, this green line should be more than half compared to this line. So let me explain what I mean. Can you get a count for how long this red line is on the y-axis? Only on the y-axis. It's not going to be much too difficult. Have a look. Have a look. Let's say that this endpoint is 1 division above this line. So this red point is starting from here. Can we agree on that, everyone?
Yes, sir.
Yes, sir.
This is the highest point of your red line, and let's say that the lowest point is somewhere over here. So let's say over here. I'm taking a bit more because so that I don't mess it up. So have a count. How many divisions do you have here? Have a look. 5, 10, 15, 20, 25, 30, 35, 40, 41 divisions. Make sense? So we have a total 41 divisions, which is covering the red line on our y-axis. So this green line representing points, that should be more than 20. Because we have 41, more than 20 would mean as at least 21. Sorry, more than 20 means at least 21. So 21 is more than half compared to 41. So let's have a count. How long, how many divisions does our chosen points cover on the y-axis? This is the point, and this is the point. Let's have a count for how many divisions do we have between these 2 points. Have a look. Here we have 1, so I'll forget the 1 for the time being because I'll add it later. So let's say I start from here. I'm starting the count from here. So 10, 20, 25, 27, and then 28. So my y-axis line is altogether over here. I have 28 divisions. Where this much was how many divisions? 41. So I can very well comfortably say that my line is more than half on the y-axis. The same step you can proceed for the x-axis as well. What I mean is that you can also count how many divisions does it cover from here to here, so that you can essentially have a measure that how many divisions are here. Then you can calculate out how many divisions are here on this axis as well. This is a bit of an elaborate or time consuming way, because you really need to have a look in the graph. Easier way is that you use a ruler and measure the distance, and if you're good, you move on. এই প্রসেসটা কি বুঝা গেছে সবার? How to
Sir,
choose the coordinate points and how to draw the triangle.
Yes, sir.
One more thing, একটু শেষ করি, আমি একটু শেষ করে তারপর কোশ্চেন নিচ্ছি, একটু হাত উঠায় রাখো, আমি কোশ্চেন নিব। One more thing that is very important for you kids to be very careful about, which is messed up by the students in a lot of cases, is that students don't take into account the power of 10 that might be labeled on your graph. Power of 10. What do I mean by that? Power of 10 মানে হচ্ছে, I have to pick this call because I am having a very special book delivered for me. I'm sorry, just wait a bit.
Okay, sir.
Yes, bolo. Yes, what seems to be the trouble?
Sir,
Yes.
Shoji didn't understand it.
sir, I was just missing.
You're missing what?
Nah, I was just missing around.
You don't mess around.
Sir,
Don't be, unless you can actually mean it. But it's okay. সমস্যা নাই. I had to pick up a call. I really had to pick a call. I'm having some books delivered for sampling for my A-levels kids because they cannot access the book because the Nirkhit is off and everything is not very much accessible. So I'm planning to bulk order some books. So I had to pick the specimen up. That guy just showed up after closing his shop. Okay. I'll take questions in a bit. Just one more second. That is how I talked about this gradient and okay, হ্যাঁ ঠিক আছে, হ্যাঁ একজন করে কোশ্চেন বলতে থাকো। হাত উঠে রাখছো একে একটু ওয়েট করো। সজীব, yeah, go ahead. সজীব,
sir, my question was that why is it necessary for the triangle to be more than the half of the line?
okay, good question. Let me elaborate this idea. The way we define the geometric concepts of points and lines or surfaces or planes is that what is the geometric definition for point? Can anybody define point other than googling it right now from your own head? How do you define point? Define point. What should be your answer? Think and respond. I would like to have some response.
Random coordinate in a graph.
That's correct. One of the key things that you really need to understand, that a point is a geometric thing which does not have any dimension, which means it doesn't have any length, width, or height, anything. It just exists. So it's basically a coordinate. A point means a coordinate in a three-dimensional space or in a two-dimensional plane. It means a location. It's not essentially a thing. Now, that's the idea of a point. A point does not have any dimension whatsoever. If you if you start moving a point, that will trace out its certain thing as it leaves from one point to another point. That thing is what we call a line. A line essentially has only one dimension. It has length. It doesn't have width. Doesn't have height. Now, if I ask you to visualize a line in your head, you cannot do that, because anything that you try to visualize will always come with some thickness. You in your head or I in my head cannot visualize a line or a point by its absolute definition, because we cannot think about things which do not have width. If you are seeing a line in your head, that will always come up with some width, and that will always be a very thin rectangle. It's not going to be a line per se. Now, why am I blabbering about this geometric idea? Because whenever these lines will be printed in your printing scenario, these lines will have some thickness, because non-zero thickness lines cannot be seen or printed at all. So, and all the pencil that you will be using are expected to be sharp. They shouldn't be dull, and those pencil lines will also have some thickness. This thickness is essentially what gives us a bit of a trouble. What I want you to understand is this. I'll be taking a long amount of space, big amount of space to give you this example, because I really need this one big space to make sense out of it. It's 25%. Okay. Let's say, so 50%. Let's say if I take two dots which have thickness, because we are working with pencils and printed lines. So let's say I'm gonna take two dots over here. Let's say this is one black dot that we have, and I'm gonna fill it up with black as well. So black, honey. Achha, let's say I'll fill this up with black, and let's say I'm gonna copy this and make up 2 more points. So let's say these 2 points are placed pretty close to each other, and in another case, for another line that you're trying to draw, these 2 lines are placed to pretty far away from each other. So what I'm gonna try to do, draw a straight line through these points and also draw a straight line through these 2 points as well. If I give it a try, have a look. Points which are pretty far apart from each other, they cannot have too many lines passing through them. So I have chosen, let me choose the same thickness as nearly to the diameter of this thing. So I'm intentionally choosing a pretty thick line. Now let's say this is the straight line that is almost correct for these 2 point positions. Okay, so this is, let's say this is the correct line that should happen. I can see it that I have tried my best to make this straight line pass through the nearly the center of my 2 points. So this is supposed to be my best line. The possible mistaken lines which can still go through these dots could look like this. Let me draw them with a bit different color. Let's say red. Black darker chilo. Black. Let's say the next miss line or wrong line could look something like this. Check this out. Have a look at the variation between the red and the black line. You will see that this red line also does touch the black circles. Do you see it? But this part on the top side, it is going somewhat higher than the midpoint, and on the lower side is going somewhat lower to the midpoint. But if you are asked that does the red line pass through the 2 printed points, you can say yes, because these 2 printed points are not printed as points; these are printed as circles, small circles. So because of these 2 things, you can have a slight variation between the 2 lines. You can essentially see that the gradient value for the red line and for the black line are not going to be same, are they? Respond.
No.
Which one is steeper? Which one should give you a bigger value of m?
The red
The
line.
red one.
Red one.
The red one
line.
should do. So,
Red
backটা discard করো, just বইগুলো ভিতরে রাখো. The red one. So this red one will essentially will have a bigger gradient. So there is always a chance. Thank you very much. So this will give us a chance. So this will give us a probability of mistake, error. You can essentially understand that this red line is not properly drawn. The black one was better, but there is a probability of this much error that can happen between these 2 lines when the points are this much apart from each other. Let's try and achieve that same error for points which are placed closer to each other. Let's try and do that same error. So I'll do that same drawing over here once again. Let's say I'm gonna try to draw this with black. Black, yes. So let's say I'm gonna try to draw the proper line that is nearly through their centers. So trying that. Almost through their center. So this could as well be the best line, which goes pretty much through their centers on both of these small circles. The wrong line, which is marginally acceptable but definitely not the absolutely correct one, might as well look like this. Yes. You see, this red line is essentially correct because it is also passing through those two circles. pretty well. Do you see that? I mean, the logic by which this red line was acceptable, by the same logic, this red line is also acceptable, because this is essentially passing through these two circles. You should be able to see it very clearly that the angle between these two lines is much too larger compared to the angle between these two. Do you see that?
Yep.
This problem is only arising because these points that through which we are trying to draw those lines have diameter, and the line that we are trying to draw has thickness. If we could draw geometrically defined points, no dimension, that is point, and no thickness, that is a straight line, then this close or far apart would not be a factor. But since our drawn lines or printed lines will always come up with some thickness, that's why we have to take care of it by appropriate process. And that appropriate process is defined as to take those two possible points pretty far apart from each other. So the farthest, the better. For your convenience, the minimum distance that was defined by your syllabus people, CIE people, is that these 2 points should not be as close as half of the given line. They should be at least more than half of the given line apart. Do I make sense?
Yes, sir.
Yes.
So that was the answer for why do we have to put the lines, put the dots pretty far apart from each other, so that this error is less. You do understand?
Much more, broadly used sensitivity input for every good reason.
Sir.
Although Unknown Army is considered one of the best controller players, and he
Aryan, stop playing YouTube videos.
No, I'm not playing.
Acha, Arif na. Someone else
Who is
who is feeding this noise.
Guys plays on
No,
the
I'm not doing.
So it's just really safe to say that this is the more consistent.
All right, my bad. All that I can see from my participant list is which of these microphones are flickering. So you are talking around. Hold up. I mean, I'll take the questions one by one. So Sajid Shaka, did I get your question answered?
Yes, sir.
Adin bolo.
স্যার এইখানে যে পিঙ্ক কালারের লেখাটা লিখেছেন ওইটা একটু বুঝি নেই।
Eta.
জি স্যার।
What I meant over here is that, let's say the line that they have given in your question, this line is supposed to have an exact gradient of this much. They did their best drawing and they came up with this number, but the kids can choose points which can be slightly more or less. So their calculated gradient can have some error compared to the exact value that the examiners came up with. So typically in the mark schemes, there is an acceptable range for the M value. So you're given this red line, you're asked to draw the gradient, but you are given the range in the mark scheme that if this gradient calculated by the kids or students fall within this range. So it can be as small as 0.1866772. It can be as big as 1.0472. এই রেঞ্জের মধ্যে পড়লে তাদেরকে full marks দেবে. Typically they give you a range. They do not specify stipulate one specific value. So in most cases, unless you are really dumb or you made a really big mistake, you would be covered within this range as long as you know how to draw the proper gradient. So this is the information that is usually added in the mark scheme. This is the actual true gradient, but just to be liberal to the students, they give some range of this error. So you have a margin of error. You can do your math with some confidence. You don't have to be extremely conspicuous about it. বুঝা গেছে?
জি স্যার।
Okay. Arif bolo.
স্যার আপনি কি জানি সেকেন্ড টাইম একটা মানে লাইন আবার একটা এরকম সিমিলার টাইপের লাল কালো একটা লাইন এঁকেছিলেন, এখানে কি বুঝাইতে চেয়েছিলেন? সেকেন্ড টাইম যে এই লাইনটা এঁকেছেন,
that the difference of the gradient calculated from the actual true line compared to the possible wrong line is more. Here the amount of error that we could possibly do is more compared to the amount of error that we could do over here. So if you have your points pretty far apart from each other, the possibility of error is less. If you have your points pretty close to each other, your possibility of error is more. That's why we would appreciate those 2 points to be pretty far apart from each other. That is one of the reasons for which we say that these 2 points that we choose for our gradient drawing should be at least more than half compared to the given line. বুঝা গেছে?
হ্যাঁ স্যার।
Achha. Any other question, anyone, about this process?
No sir.
Achha, ঠিক আছে. So let's move on to the next part of our lecture, which would be how can we how can we measure the gradient for a curve? আচ্ছা কার্ভের গ্রেডিয়েন্ট আঁকার জন্য আমি আগে একটা কার্ভই আঁকি so let's say this is our axis system I shouldn't use this much thickness let's say I go for a smaller thickness black is our axis system তাও হয় নাই আচ্ছা never mind so let's say we are given a curve which looks like this okay so we are asked to calculate the change of gradient or we are asked to calculate the gradient of this curve for a specific point one of the key part that I need to understand unlike straight line curves do not have a single gradient because this line is slowly becoming steeper so it was pretty flat at the beginning and as we slowly move from x to move towards right of the graph or increasing value of x this graph is slowly becoming steeper and steeper and steeper so any curve does not essentially have same gradient at 2 points if I'm using the word essentially because in some cases you can have same gradient for 2 exclusive point but it's not always true for example for this curve you will always have different gradient for all the points so you cannot measure you cannot essentially say that you measure one gradient of this curve at one point and that gradient is applicable for all the other points that's not gonna work out that's not gonna be appropriate so you need to calculate the gradient of all the individual points individually if you are gonna go through that process so what do I mean by calculating the gradient for example let's choose a single point let's say I want to calculate the gradient of this graph at this point it's over here okay so এই পয়েন্টের gradient আঁকার জন্য ফার্স্ট আমাকে কি কাজটা করা লাগবে I have to draw a base fit tangent through this line আচ্ছা এই পয়েন্টটা অ্যাকচুয়ালি আমি এখানে নেই so let's say I want to draw a tangent over here so tangent আঁকার জন্য the first sorry to measure the gradient of this curve I have to draw a base fit tangent over here and a tangent is a straight line so let me try and draw the tangent and I'll tell you in a bit how to choose the best tangent whenever you are drawing this with your ruler and everything for in your actual scenario so a base fit tangent might as well look like this now what do I mean by this thing I'll take this a bit out so that I can move this for my advantage let me elaborate this information that how can you choose that your tangent is your best fit tangent what I mean is that you can essentially have okay you can essentially have this line could appear to be your best fit tangent in some cases it might be in some cases it might not be so should you draw a bit more steeper line or should you draw a bit more slanted line how do you define that how do you do this part of the lecture that I'm going to do right now is not essential that you meticulously follow but this is something that I want you to know because as long as you know how to check your errors you would be always able to do better graphs so the part that I'm trying to show you right now
আমি
is
আপনাকে শুনতে পাচ্ছি না
আমি তোমাকে খুব ভালো শুনতে পাচ্ছি
Sir, is this randomly or like?
no there is a logic to this which I didn't show yet I'll show you এটা কে বললা আমি তুমি আমাকে শুনতে পাচ্ছ না who said that hello
চ্যাটে লেখেন তো বুঝতে পারছে না
Tasnim Fariha has left the meeting I might as well turn my waiting room on so that I can see if there is someone who is extremely late or who are having internet connection problems. Ali Barian, if you don't have a question, please drop your hand. It's not necessary. So let me say I'm going to select this line and I'm going to show you what do I mean by this. Transparent selection. Beautiful. Control C.
স্যার কথা শোনা যায় না কেন
আদিন আমি তোমার কথা খুব ক্লিয়ার
ভাইয়ের
শুনতে
কথা শোনা যাচ্ছে না যে।
Can everyone else hear him?
Yes, sir.
Yes.
Clearly শোনা যায়।
Hello.
না না আমি কোথায় গেছি?
All right, have a look at what I'm trying to mean when I say that this line is supposed to be where. Whenever you draw your tangent, you should be careful not to draw a tangent like this. There should not be any gap between your curve and your straight line. So the green one is a straight line, and the red one is your curve. So I have made a high amount of zoom to show you how to draw this properly. And then again, your tangent should look like this. So have a look at what I'm trying to achieve here. I have tried my best to perfectly overlap the green line over the red curve at the end point. So I did not do this, neither did I do this. For both of these cases, you can see that my tangent is not essentially passing through the exact point that I'm aiming for. But if you have a perfect overlap, so overlap means that you have covered the red line with your green line at the point that you're trying to draw your line at. So if you can achieve that, that's your best position in terms of vertically or horizontally. That's point one. As for the alignment, what I mean by alignment is that should your line be more steeper or should your line be more slanted? How do you choose that? How do you choose the alignment of your ruler? This is a simple rule of thumb. What you need to do, if you just look at this graph and take a good look at this graph, I need you to find out an approximate length of the common length of these two structures. Common length, I mean beautiful airplane mode, best thing. So common length essentially mean that, let's say I'm going to label this with navy blue, and I'll choose a thinner line. Have a look from the center point of your aimed point. The part where these two lines get detached from each other is up to here. You can see that there is this hot pixel, white pixels are being seen over here. Do you see that? Right over here. This is where the white pixels are starting. Do you see that? Which means before this point, up to here, up to this much length, the red and the green lines are overlapping each other. Can you agree on this one? Have a look.
Yes, sir.
I'm talking about this much length where they are overlapping. So copy. So there is a certain point, and when you have drawn your tangent, from where you will you'll start to see the white of your page. So before up to that point. So this much is the length on the right side, and on the left side, this much is the length. If your tangent is supposed to be perfect, or if your tangent is supposed to be acceptable, these two lengths are supposed to be nearly equal. So I'm using the same symbol approximate. These two lines has to be almost equal. The closer they are in terms of length, the best your tangent is with respect to your curve. Now, if you see, so if you wonder that should we really try to achieve this by pinpoint accuracy, the answer is a solid no. But if you see some really wide variation, then you should really reconsider the position of your graph. What do I mean by this? Let's say I'm gonna go ahead and do Control Z's, and let's say I draw another line over here just to make the understanding clear with you. Let's say I'm drawing a line like this, which is slightly different compared to my purpose. So let's say if I draw a line like in this orientation, which is a bit more different. Have a look. Let's say I am drawing my tangent line in this fashion. This line also essentially passes through that point. This was my point. But you can see on the left side, the common space is only very small. How much is the common space? The common space is over here is only this much. So I have to choose small thickness. Let's say choose sky blue. On the left side, you only have this much common space, whereas on the right side you have a very large amount of common space. Do you understand the meaning? What I mean by the Do you get my point? What am I trying to mean by using the word common space?
Sir,
Yes, I mean overlap.
how will we know that which one is the center?
Oh, that will be given to you in your question in many cases, that calculate the gradient of the curve at this coordinate. So you can find out that coordinate. In most cases, this will be given to you. You'll be instructed to calculate that for a specific point.
Okay, sir.
Okay. So do you see that here visibly, I mean, just by looking by your eye, you can see that these two common regions, they are not even equal. They're not even nearly equal. Do you see that?
স্যার একটু আগে যেটা বুঝিয়েছেন সেখানে আমি ছিলাম না স্যার, আপনার কথাগুলো শুনতে পাচ্ছিলাম না, একটু আবার বুঝাবেন?
No, we are already past that point, but I will upload that in the YouTube, so you better see it from there. So if you have a situation like this, then you need to reconsider the alignment of your ruler. So what I mean, reconsider alignment means that you need to tilt your ruler a little bit more so that you could achieve the earlier situation that I just explained. So it doesn't have to be pinpoint accurate. Pinpoint accurate মানে হচ্ছে এখানে 2 cm, এখানে exactly 2 cm হতে হবে. Don't bother for that. But what I'm trying to put in your head is that what is the standard to do this? You don't have to achieve this by 100%, but as long as you know how to draw this properly, you should be able to at least try to draw it properly, and that is good enough. Do I make sense so far?
Yes. Yes, sir.
Yes, sir.
Yes, sir.
So these are the considerations that you need to put in whenever you are dealing with curves. So the point that I was saying, that a curve essentially will have different gradient at different points. For example, if you have this was not correct, so let me just get rid of this whole thing, and I can paste my original line. Let's say, should I paste my original line? Okay. Beautiful.
Sir, do we have to measure the common space?
No, you don't have to. You just have to measure it by eye. You don't have to use a ruler. Just looking by your eye, if you're comfortable that okay, they are nearly equal, move on. It's perfectly good. But if you visibly see that one part is extremely small compared to the other one, then you better reconsider the alignment of your line, because you might get a really different value compared to the in that case your calculated gradient value might fall outside the range of the examiner's mark scheme.
Okay.
I cannot control Z. I can. Okay, so let's say we have drawn this base fit tangent, which was our first line, and then you can calculate the gradient of the curve exclusively at this point by measuring the gradient of this tangent. Once again, if you draw this much of a tangent, it is recommended that you better draw a big enough triangle over here. So you draw your triangle, you calculate the delta y, you calculate the delta x, then you go ahead and calculate the gradient of this point. So that is how we go ahead and calculate the gradient for a curve for a single point. If you want to measure the gradient for gradient of the curve at a different point, you have to repeat the whole process. For example, if you want to measure the gradient of the curve over here, you have to draw another tangent. So you have to repeat the whole process, and that gradient value would be somewhat different compared to what you just get. For example, if I want to measure the gradient over here, I might as well draw a tangent like this. This is too thin for my purpose, so let's go for this one. So let's say over here, you can see over here that this is a bit more slanted line, but what I'm trying to obtain is that whenever that I am not drawing it over here, or I'm not trying to draw it over here. I am trying to put it exactly at the position so that they are perfectly overlapping at my aimed point, which is right here. And they have almost equal length on both sides. I'm not measuring by ruler, I'm measuring by eye, or looking at by eye. So I have this much tangent, and then also I'm gonna go ahead and draw another triangle. Let's say I'm gonna draw this with brown so that you don't confuse them. So I'll be drawing here another triangle, and this will be my second delta y and second delta x. You can calculate the gradient of this point as well. The point that I'm trying to make is that for a curve, the value of gradient is different at every point. Curve do not have a single gradient. Straight lines have a single gradient. Straight lines have the same gradient all over, whereas the curves have different gradients in different parts of the graph. বুঝতে পারছি?
Yes, sir. একটু বুঝাবেন?
হ্যাঁ বলো। বলো আলভিনা,
আবার আবার একটু বুঝাবেন?
কোন পার্টটা?
এই যে পার্পল কালারটা।
I have blue. This one?
স্যার।
Oh, here I meant that we repeat the same process that we did over here. So, but we just draw a different triangle. We just draw a different triangle and to measure the gradient of a different point. The highlighted part of information for this lecture part is that different points of the curve will have different gradients. So you cannot simply measure the gradient of a single point and say this is the gradient of the curve. Gradient of the curve is not a full information. Gradient of the curve at this point is this much. That's specified. Or gradient of the curve at this point is something else. So at every single point on the curve, you'll have different gradients. So if you want to try to calculate gradient at different points, you have to go through the entire process for each individual point. In most cases, you don't have to draw this more than twice. In most cases, let's say 90% of the cases, you have to draw only one tangent and go ahead with the calculation. But in some cases, in 10% of the scenarios, when you're given a curve, you might have to draw two tangents. I mean, if I give you some sort of a comparison between straight line curve graph and curve graph, I mean, about 75% of all the graphs that you would have to deal with are straight line graphs. 25% of them are curve. Among those 25% of the curves, 90% of the cases you'll have to only draw one tangent. 10% of those curve cases, you might have to draw a two tangent points. So it's pretty rare, but it's better if you know for the completeness of the whole understanding.
The coordinates will be given, right?
Yes, the coordinates will be usually given to you. Yes, you don't have to. You usually have to judge them, because if you have to judge, then the examiners will have to measure the coordinates of all the points of the whole graph, which will be very difficult for them to even work with. The mark scheme cannot specify. Unless the question specifies you the coordinate, then the mark scheme should provide the examiners the gradient value for all of the points on this curve, which is highly difficult per se. Make sense?
Yes, sir.
Yes, sir.
So I'll move on from this point, and so that is the part that was my curve. So yes, this was this part. Okay, so I'm gonna try and cover to slowly go in the equation of curves that I did talk about with you last class. So let's say there was a general equation that I did write, which I did not say, and I really did not explain to its fullest in our last class, which looked like this: k into x to the power n plus c. This was the type of equation that I did write. Do you remember? In most cases of your O-level, you don't have to be on a write the question in the public chat so that everybody can see this thing. Oh, তুমি originally লিখছো, sorry. আচ্ছা, Ono give us a question in the chat window that is, can we use differentiation if the equation is given? We can use differentiation mathematically speaking, true, but if the graph is provided to you along with the the physics examiners, they highly appreciate that do your calculation using the graph. But differentiation would not be mathematically wrong.
Okay, sir.
Differentiation would not be mathematically wrong, but it's appreciated that you leave your traces and do your drawings on the graph, and so that the examiner can judge you properly with what did you actually do. For example, let's say by doing the differentiation, I can very easily find out the gradient of this point. I mean, if your equation is given, you do the differentiation and you place the coordinates, you get the gradient exactly by mathematical procedure. But in most cases for physics experiments, you might not as well have an equation when you are doing an experiment. For example, let's say you are drawing the cooling curve of a hot object placed in atmosphere. I'll tell it again. You are drawing the cooling curve of a hot object placed into atmosphere. So you have a hot piece of metal. You have just took it out of the furnace, and now you have put it in atmosphere. It is cooling down by dissipating heat to the atmosphere, and you are taking the temperature reading, let's say, every 1 minute. So in that graph would essentially look somewhat like this. It will be a sort of a negative exponential curve. Or if I go ahead and try to draw this, that curve is gonna look, let's say this is my room temperature level, 25 degrees Celsius, typical room temperature level. And let's say your starting temperature was over here. That line is gonna look like this, somewhat like this. It's gonna slowly become asymptote with your room temperature. So this will be a curve that will get from your experimental data, which will be a best fit curve. But in a regular case, from an experimental set of data, you would not have the equation. So in most cases, we do not have the equation and go ahead and plot the data. It's actually usually the other way around. We have the graph, but from experimental data, we have the shape, and then from the shape, we prefer to come up with the equation. So that's why in most cases, the equation of the curve would not be available to you. If that makes sense or not.
Yes.
So we are trying to manipulate property or calculate out property from the experimented data, not the other way around. So এখানে আমি তোমাদের যে কার্ভের যে ইকুয়েশনটা দেখাইছি এই কার্ভের ফুল ইকুয়েশনের ইমপ্লিকেশন তোমাদের ও লেভেলসের জন্য কখনোই লাগবে না, but I really want to make sense with all of you kids. So last class we only talked about y equals to x to the power n. I only talked about this part. So whether if this n value is bigger than 1, then we'll have increasing gradient. If this n value is less than 1, then we'll have decreasing gradient. That this much part we have covered. What is the implication of k? K essentially makes the n, what is k will make this n value n times bigger. So what do I mean by this? Let me just show you this thing in Desmos once again. So simple thing, pretty much like yesterday's class. Let's say we are gonna go. I'm writing the y equals to x first, which is our red line, which is our typical reference. I always place this in the graph so that the kids can have a understanding for what is happening. Or oops, I did not want to. Okay, this one is okay. Okay, so we are gonna try to have a look over here. So then let's say I'm gonna place y equals to, where is y? Okay, y equals to x squared. X squared. So we have a line like this, which we also discussed last class, that we're going to have a crossing through the 0, 0 and 1, 1 point. And now if I just put a 1 multiplier in front of this x squared, let's have a look what is happening. So let's say if I write y equals to 3 x squared. So this is pretty simple. Now what I need you to understand that because I have used a 3, it means all of those x coordinate values would be multiplied by 3 to get this point. Which means when x is placed as x equals to 1, then you would get 1 square into 3. So y coordinate should become 3. For x equals to 1, y equals to 3. Have a look. When x equals to 1, y has made the cutoff at 3. So all of your y coordinate values compared to the blue graph, the green graph, would have 3 times bigger y coordinate value. So 3 is just a numerical multiplier which will make your graph becoming steeper faster if it is more than 1, or if it is less than 1. For example, let's say if I write y equals to how much should I write? Let's say 0.5. I'm using half. 0.5 x squared. Yes. If this is the case, so this one, the violet graph or purple, what do you call this color?
Purple.
Purple? Is it purple or violet?
Violet.
Okay, violet, purple, whatever. However it looks in your screen, it's also dependent on the screen quality. So violet, purple, whatever. So if I use a multiplier that is less than 1, then that graph coordinates would be lower compared to the y equals to x squared. So the idea is very simple. This green graph, for the same x value, hear me out clearly. For the same x value, the blue graph is y equals to x squared. The green one will have 3 times y coordinate value compared to the blue graph. So for example, when x equals to 1, the blue graph is having x equals to 1 equals to y equals to 1. So it's having a coordinate over here, 1, 1, the blue one. Whereas the green one is having 3 times the coordinate. Similarly, if you go for 2, when x equals to 2, y equals to x squared. So for the blue graph, that 4, where is the 4? Here is another point. This is 2, 4. This is another point. But for the green graph, this will be 3 times as much. So 3 4s are koto hoy?
12.
12. So we should be able to find that point. So I'm zooming out just so that you can have a look at the grid. So here is your 2. You see, if you go above, here is your 12. You are having a cross point at 212. So that's the point of having this multiplier. So this multiplier will simply make your y-axis value bigger, or if it's less than 1, it will make your y-axis value smaller. For example, here we wrote half. So if I go for this one, when x equals to 1, for x equals to 1 for this curve, you would have 1 squared, but for this one, you'll get half, because 1 square gives you 1, multiplied by half gives you half. So have a look. When x equals to 1 for the purple graph, that is, when x equals to 1, your purple graph is giving you 0.5. Just half of that blue graph, because the multiplier was half. So these numbers would essentially essentially give you an idea that how fast should it get, step up, or should it step up slowly. You need to understand one thing very clearly. The physical description for all of these graphs, green, blue, or purple, is same. The physical description is that all of these graphs have increasing gradient. Increasing gradient means initially their gradient is really small. As you slowly go from left to right, they are becoming steeper and steeper and steeper. All of these graphs are following this property. But that is happening more rapidly for the green one, slightly less rapidly for the blue one, even more or less rapidly compared to for the purple one. That's the significance of this number. If you have any question, ask me.
Sir, I don't understand the point thing.
Which part?
The points, like you were finding out the points of each line. I don't understand the part.
Yeah, তোমার চ্যানেল থেকে প্যাজ আসতেছে. Could you please write the question in the public chat? I really appreciate that. By the time Dia writes her question, anyone else, did you understand what I'm trying to mean over here for the significance of this multiplier?
Yes, sir.
Oh, to have you I give you an idea for how these lines curve out, I actually tried to place different x values and calculate the relevant y values in my head. So if you place x equals to 1, y equals to x squared, this equation gives you a y value of 1. 1 square gives you 1. If you place the same x equals to 1 in this green equation, you will get 3. 1 square gives you 1 multiplied by 3, so y value becomes 1. So that's what I was trying to say, that for the green graph, for the blue graph, which is y equals to x squared, x value 1 gives you y value also 1. So 1, 1 is a coordinate of the blue graph. But for the green one, whenever you place x equals to 1, your y value should become 9. So for 1, this crossing was happening, 1 was here. So this is the 1 line. So I'm gonna be dragging. So if I go ahead, 9 কোথায় গেল? Sorry, 9 na, sorry, 3 বলতেছে 9 na. If you place 1 over here, it's 1 square into 3, so y coordinate should be 3. So here is your 1 and here is your 3. This one. So the point that the difference between these two graphs is that for the same x value, all the y values that you're going to get for this graph, the relevant y values for the same x value for this graph are going to be only 3 times as much. This 3 is giving you a multiplication factor for the y coordinates. That's what I meant. বুঝা গেছে? Hello.
Yes, sir.
So this was the part that we over here, and then if we go for the remaining thing, which is C over here, this is basically the y-axis intercept. I mean, any single time you see something, I mean, y equals to some expression plus C. This C always means the y-axis intercept. Y-axis intercept means that if you place x equals to 0, what you'll be left with. So have a look. If you place x equals to 0 over here, irrespective of this equation, x equals to 0 বসালে 0 to the power n gives you what? 0. Because 0 to the power anything is 0. Right?
Sir, what is K?
Yes.
Sorry?
What is K?
What is?
K.
K is the numerical multiplier that you can have in front of the x square. For example, this half, or for example, this here it was 1, here it was 3, here it was 0.5. The multiplier of x squared, or coefficient, if that's a better word that you are acquainted with. বুঝছো? আচ্ছা, And the C is the y-axis intercept that you can have whenever you place x equals to 0. So which means that at what value this will cut off our graph. Now I'm going to be changing these equations a little bit for this to make it sense with you. All of these graphs has their intercept value 0 because we don't have any plus c over here. We don't have any plus c's over here. But if I place some plus c over here, let's say if I don't write y equals to x, if I write y equals to x plus 5, let's say, okay. So why would that line be? This line would pass through the curve. Should I write y equals to x plus 5? No, I better write y equals to x plus 2. Okay. So if I write y equals to x plus 2, this means that this would be a straight line with gradient 1 because over here nothing is, have a look, try to compare this equation with the shape y equals to mx plus c. Y equals to mx plus c, which is the generic equation for the gradient form. So what should be the value of m?
1.
It should be 1. Can everybody see that? Nothing is given over here means what? What is the coefficient of x? Essentially
1.
1. So if you compare the equation with y equals to mx plus c, the gradient of this line is 1 and the y-axis intercept is plus 2. That's pretty much what this red line is about. If I add the same plus 2 for this equation, let's say plus 2, the only thing that's going to happen here that your entire curve is going to rise up and give you a y-axis intercept at 2. Which means if you place x equals to 0, try to do this calculation in your head. If you place x equals to 0, what do you get? Y equals to 0 square plus 2. So what is your coordinate? Essentially, your coordinate is 2. So this last part gives you the y-axis intercept, which means whenever x equals to 0, what is the cutoff value for that graph? So that much that this one means that. এই part actually তোমাদের syllabus জন্য always জন্য খুব একটা important না, but this is pretty much the basic generic expression for a simple curve. So that's why I wanted to show you. I can essentially go for other variations that I did talk about last. For example, if I write an equation that looks like, let's say y equals to, let's say 2.5 x to the power, where is x? X to the power let's say 0.7. So this power is less than 1, so this should be decreasing gradient. Let's say plus 3. So you can see what is happening. This graph is starting from the 3 point. This is the black one, because if you place x equals to 0, you will get this one, and then it is starting tangent to the y-axis because this power is less than 1. So this will be slowly losing gradient. Have a look. It's losing gradient. Take a look at the black graph. I'm zooming it out. Take a look at the black. So you see, this is slowly becoming more and more slanted. All of the earlier lines, they are becoming becoming more steeper, or the black line is slowly becoming more slanted. The reason is this is 0.5, this is 0.7, less than 1. Make sense?
Yes, sir.
Okay.
Yes, sir.
Fabi Harim Hossain, bolo.
So, what's the value of x in this graph?
I'm sorry?
What's the value of x?
What's the value of x?
Yes.
The value of x is not a definite value. By placing different values of x on this equation, you can find out relevant values of y. And joining all of those x and y coordinate values, you can get this curve. So x doesn't have a fixed value for you to work with. But to judge the correctness of the graph that we have on the software, you can essentially put some convenient number over here and go ahead and calculate that value. For example, if one of the easier number to work with would be, let's say x equals to 1. Easier number because 1 to the power anything gives you 1, so that's easy to work in my head. But if I want, I can do the calculation for any other number as well. So you can put any number of x over here, do your mathematics with this part, and then you can find out the y coordinate. And those coordinates will be plotted one after another, and by joining those coordinates, you can get this whole straight line. So x doesn't essentially have a fixed value for any of these graphs. You can use a lot of different values. I was choosing some numbers for my convenience, which I could calculate mentally. So I used 1, I used 2 because they were easy to work for me. But if I choose that, let's say I want to calculate this y value for x equals to 0.365, I cannot do that square in my head. So I didn't go for that. But those values are also included. They are not excluded. That's the part that you need to understand.
Okay, I understood now.
Beautiful. So that was the part of bit that I wanted to explain for the case of the curve. So this is the basic formation for curve and so on and so forth. The one thing that I would also like to, this is simple graph. The one thing that I would like to also explain for the discussion for curve is that how do we work with sine curves or cos curves? You guys all know how sine curves and cos curve look like. Do you know this thing? Sine curves look like this, whereas cos curves look like this, right? That's pretty much the basic difference in shape. Sine curve starts from 0 and makes this up and down motion. Cos curve starts from 1 or maximum value. That is, if you wonder what do I mean by maximum value, it is always 1. Not essentially. Let's say y equals to cos x or cos theta. That will have a maximum value of 1. What if I write y equals to 10 cos theta? What should be the maximum value of this curve?
Sir, can you repeat the question?
Yes, the question that I was saying that what should be this number over here, that highest value of the cos curve, is dependent on your equation. If I write an equation y equals to cos theta, only this much, nothing else is given. That means your equation should look like the highest value or the peak value should be +1, the lowest value should be -1, because the value of cos theta changes from +-1. Do you know that?
Sir.
Did you kids do sine theta, sine curve or cosine curve in your maths?
No, we haven't. Not the curves.
Okay, not the curves. Okay. Then I better not get into that because I will be needing this equation much too later in the waves chapter. So we can skip this part for the time being. আচ্ছা এটা আমি পরে তোমাদের যখন waves chapter আসবে তখন আবার আলাদা করে বুঝাবো. Don't worry about that. তোমরা আগে mathematics এর basics করে নাও so that it will be easier for you to grasp, and I have to do less work. So yeah. For the time being এটা বাদ, এটা লাগবে না এখন আমার. তোমরা আগে ইয়া পড়ো কি বলে ওই যে maths শিখো, then we'll pick this up. So that's pretty much it about the itsy bitsy parts for the graphs that I wanted to discuss. And there's one more thing that is entirely left which I did not cover. All of the discussion that I had done up till now were all about gradient, right? There is one more information that we can get from the graph. To be honest, from the graph we can get 3 set of information. তোমাদের কাছে কাগজ কলম আছে না, কপি আছে না? লাস্ট একটা সেন্টেন্স লিখছিলাম, মনে আছে?
Yes, sir.
Yes, sir.
So you wrote the definition of gradient. তার নিচে একটা বুলেট দাও, ওই সেন্টেন্সের নিচে একটা বুলেট দাও, বুলেট দিলে একটা ইনফরমেশন লিখো, বলতেছি আমি। একটা সেন্টেন্স লিখো, সেটা হচ্ছে any graph can give us 3 set of information. Any graph can give us 3 set of information. Information is a singular. Information can never be plural.
Any graph can, sir?
Any graph can give us 3 sets of information. Number 1, sorry. Number 1, value of y for value of x value of y for a known value of x and vice versa.
Sir, can you repeat?
Value of y for a known value of x and vice versa. সিফানা, তুমি কি ক্লাস করতেছো? আরে উইথ আস?
স্যার আবার একটু বলবেন।
সিফানা, তুমি কি ক্লাস করতেছো আমাদের সাথে? আর উইথ আস?
Yes.
কই? আচ্ছা আজকে আচ্ছা, ওকে ফাইন. Did you join with your own account or with your mom's account?
No, I did join with my account. আমার একটাই Zoom account. আমি just Messenger-টা just switch করছি, that's it.
Oh, আচ্ছা ঠিক আছে, okay fine. I'll process you after all the classes are done. So এক নাম্বারটা ছিল value of y with a known value of x and vice versa. এটা মানে হচ্ছে তোমাকে যদি একটা certain state graph দাও থাকে, if you provided a graph, you can essentially calculate by plotting onto the axis. If you have an x value, you can go ahead and find out the relevant y value. Or if you have a y value, you can go ahead and find out the x value just by tracing it out on the axis system. That's very much available. So you can get pretty much all the x and the y values, relevant x and y values directly from the graph, which is a available information. This is a piece of information that is available to us, number one. Number two, lecho, gradient of the graph. Gradient of the graph.
So point number 1 to cover will win.
Nah. Number two, gradient of the graph. এরপর একটা ব্র্যাকেট দাও, ব্র্যাকেট দিয়ে লিখো what is the exact gradient and
কি লিখবো?
ব্র্যাকেটের ভিতরে লিখো what is the exact gradient and also how the gradient changes. What is the exact gradient and also how the gradient changes. Number 2 আবার বলতেছি gradient of the graph, ব্র্যাকেটের ভিতরে লিখতে হবে what is the exact gradient and also how the gradient changes. Full stop, bracket close.
Gradient of the graph, then. Sorry, sir, my internet connection is a bit problem.
Point number 3. Area under the graph.
Sorry, sir.
Area under the graph.
Thank you.
Number 3, area under the graph. Full stop. So let me elaborate this.
আপনি কি সেন্টেন্স বলছিলেন মাত্র?
Area under the graph.
Oh, acha.
All right.
Okay, sir.
I don't usually not gonna make you write a lot of stuff by dictation because I do understand that having a dictation in online class is not very efficient per se, because some of us will always have internet connection problems. Some of us will always have some difficulties because voice channel tends to work up. It's not at all the fault of the students. They are not at loss for this one, but they are at, I mean, they are not at fault for this one, but they are definitely at loss for this one. So I don't tend to do a lot of dictation, but when I do, I usually repeat the stuff for a couple of times or more as much as I feel. Then I move on to the next point, and typically I don't tend to move back to the same point once again because that makes a huge mess up for the majority part of the class. So if you ever miss out any of the part of the dictation that you couldn't catch up with because of network problem or whatsoever, keep yourself aligned with the regular class. Leave some space where you messed up the part, and later you can fill that up from our YouTube lecture very conveniently. So, but don't badger by saying, sir, repeat again. That's not gonna work for my class. That's not gonna work. I don't do dictation that way. I give certain time for a certain point, then I move on to the next point, and then I stick to that point and I go ahead forward. So, কি বলতেছিলাম? So you just wrote 3 different points. The first point is pretty simple, that we can find out the individual coordinates of all the points. And the second point was what? We can calculate the gradient of the graph for relevant requirements, and we can also find out and talk about, or we can detect how that gradient changes for different parts of the graph. If it's a curve, that is, straight lines does not undergo gradient change. And the third point is that area of the graph. I did not talk about the area of the graph up till now. Did you kids, all of you have studied physics, some physics in your O levels, right? Or in your class 8, not O levels, so in your class 8, like at least the first chapter. Yes. To some extent. I mean,
Yes.
I'm saying to some extent
Yes,
because
sir.
I'm assuming that you know the definitions of displacement, distance, speed, velocity,
Yes.
I'll redo
Yes.
these parts, but you at least know these things. Okay. So I asked you this because I need to I want to show you something specific. So I'll get rid of this whole thing. Don't need it. Let's say, how do we actually usually work with a certain graph? How do we usually work with a certain graph means that how do we analyze the gradient quantity for a given graph? Have a look. If you are given a graph, irrespective of that, let's say the graph has a shape like this. Okay, simple graph. Let's say this is our y-axis. I'm not naming the y-axis right now, but here's the x-axis. So this could be actual quantities. For example, this could be distance over time. This could be displacement over time. They're not the same thing. This could be speed over time. This could be force versus area. This could be force versus distance. This could be work done versus time. This could be work done versus force. This could be a lot of different things that you can try and plot in a graph system, one with respect to the other. So let's say you are given a graph, and if you try to calculate the gradient of any graph, this is the generic formula that I have taught you, that m is given by del y by del x. You know this equation. So in this mathematical expression, we are essentially doing the division of these quantities. So del y by del x will give essentially give you a numerical value, but in terms of the quantities, what is it that we are achieving? We are dividing the y-axis quantity with the x-axis quantity, right? Think about it. The y-axis quantity is being divided by the x-axis quantity. What I mean, if you have a dt graph, distance or displacement generic unit key, meter, time typical SI unit key. What is the SI unit for time measurement? Second. So if we have a distance graph or distance time graph or displacement time graph, we can get the gradient of this graph would be d delta d over delta t. So if you think about this, what should be the unit of this quantity? A quantity a unit key হবে?
Meter per second.
It comes to meter per second, right? So by definition, if we are given a distance versus time graph, the gradient of that graph should be speed, because distance is a scalar, quantity wise distance is a scalar quantity. So distance versus time gives you speed, and if you have a graph that is displacement versus time, that should give you velocity. That's the difference. But the unit is meter per second, which works out. In the same way, if you ever have a graph of, let's say, speed versus or time, or velocity versus time, that really doesn't matter. Speed is only the magnitude. So এটা unit হচ্ছে meter per second, or এটা unit হচ্ছে second. So if you try to calculate the gradient of this quantity, this would be some form of delta V divided by delta t, which would be meter per second. I mean, if I go for the unit, I shouldn't write equals to for the unit. I'm giving an arrow. Meter per second divided by second. So what do you get? Meter per second squared. Now meter per second squared is the unit for what?
Acceleration.
So you can essentially say that that is available from here. So it is important that as you go ahead through your physics lectures, and if you as we go ahead with the different chapters, that you acquaint yourself really well with the units of the different quantities. The better you will be at remembering those units, the easier it is going to be for you to go forward, the less you will stumble upon. Remembering the units of the quantities is, in my opinion, really important and helpful. It's not that you cannot do without it, you can, but you will actually have to go through a lot of struggle if you don't want to work with units. So units are really helpful. Units are not the bad thing, they're actually the good indicators for what we're going to work out. If I go ahead and give you some more example, I can, but before I get into the more example, I'll tell you something else. This is the information for the gradient. Similarly, you can also calculate the area under a graph. For example, let's say this was a VT graph. So let's say this y-axis. So this was y-axis. Let me put this in a box. I don't want to this one look like as a division line. So let's say this was a graph which was given us as a VT graph. So this is V equals to V unit is meter per second, and time has a unit of second. So these are slash signs, not vertical. They are supposed to be somewhat tilted. So let's say we have this graph given, and then the question tells you that what is the acceleration of the graph. So you draw so you draw a big enough triangle and go ahead to calculate the gradient of the graph, which works just fine. Then the question might tell you that what is the distance covered by this car within a time of, let's say, from t equals to 2.0 second to t equals to, let's say, 8.0 second. So let's say the question asks you this, that how much of the distance covered within this much time. So to calculate the distance, we can do one thing. What we do for the VT graph is that we draw vertical lines. Let's say this is your 2-second mark. I'm not plotting the entire scale because I'm trying to make sense with you, not to show you accurately. That's not essentially required. So let's say this is a 2.0 second mark. Let's say somewhere over here we have the 8.0 second mark, and the scale is drawn appropriately. So what we do is that we draw 2 vertical lines from here up to the graph, and now we're going to try to calculate out the area of this trapezium. And we say this much area is what we call the area under the graph that we are trying to calculate. This is the graph. This is the area under the graph. Area under the graph always means
Distance.
area under the graph always means the graph, the area that is covered between the given graph and x-axis.
Sir?
Under would always mean the graph that is covered between the area and x-axis. So that's a bit of important information, not the other way around. Not the other way around. মানে হচ্ছে area under the graph would not mean somewhat like this with the y-axis. That's not the usual way. However, the questions can be somewhat twisted to give you a bit of a identification check that is possible, but we're going to talk about those variations later. First, let me give you the general information. Yes, someone said sir.
Sir, is this a velocity time graph?
Yes. Thank you. Yeah, this is a velocity time graph. So whenever we're working with velocity time graph, if you go ahead and calculate the area of this triangle, how do we calculate the area of the triangle? The formula for area of triangle, or I can write, let's say, area. So area of a trapezium triangle. So trapezium formula হচ্ছে, we're gonna have half into what?
A plus B.
A plus B into height.
Exactly. So let's say, okay, let me write the half into a plus b into height. Height would essentially mean the perpendicular distance between the parallel lines. For example, in this case, if this much is A and if this much is B, so it should be V1 plus V2, and this much, which is 8 minus 2, 6 second, should be our H. So you can go ahead and write that. So in this case, I can write H half into V1 plus V2, if this makes sense, into 6 seconds, 6.0 seconds. So that much should give you this thing. So what I need you to observe very clearly, that whenever we are trying to calculate the area, we are essentially multiplying some amount of speed with some amount of time, right? Check this out. Half is a numerical constant that comes because of the geometric expression. But actually, if you're considering in terms of quantities, you are multiplying 2 quantities, which is one of which is the y-axis quantity, the other one is the x-axis quantity. So this multiplication gives you the area. Essentially, this would mean that if you are multiplying meter per second with second, what are you left with? Have a look.
Distance.
You are left with the unit meter, and meter is the unit for distance. So area under the VT graph would give you distance. Similarly, if you have another, if I draw another graph, for example, did you please ever read the idea of what can I say? Did you kids come across the chapter work energy power in your class 8? Anyone?
Yes.
Yes.
Most of you?
Yes.
Okay. So work is defined as the product of force into distance covered in the direction of force, which is highly different from moment. Moment also pretty much have the similar expression, but it is different. I'll talk about the differences when we eventually get into those chapters. But if for a certain object that is moving in a straight line, if I plot a graph of force over distance, this is the force that you are applying, and let's say this is the distance that the object is covering. Let's say that for some specific scenario, let's say that force versus distance graph look like this. It's like a curve like that. Okay, so let's say that the curve started from here. So this was the initial point of the motion, and this is as the object was going further apart, the applied force did vary. It was not a constant. So if you do calculate the area under the graph for a certain part, for example, let's say, let me draw that part with red. Let's say you want to find out how much was work done up to as the object covered this much distance. So you can essentially go ahead and draw, you can mark up that distance, and you can draw a perpendicular line over here, and then by some mechanism, you calculate the area under the graph. Now you can see, because this is a curve, you cannot directly go ahead and apply the formula for trapezium, can you? That's not going to be very logical, because for trapezium, the four sides are supposed to be what? Straight lines?
Yeah.
Yeah. So we cannot essentially go ahead and directly apply a geometry rule for this, but somehow we can actually, there are ways, different ways to calculate the area for this part. But the point that I'm trying to get in your head is that if we can calculate the area of this graph for this much segment, that will essentially mean that we are finding out the area of force versus distance graph. Now think about this. If you multiply force into distance covered in the direction of the force, what do you get? You get work done. Work done would essentially can also translate into the energy increase, or we can write delta E. If we do some work on some object, that amount of work that we do on the object is stored in the object as energy. In a regular world, in a typical world where there is no loss. In a typical world, I mean, in a standardized case. So what I mean is that if you multiply force into distance, force unit hoche Newton, and distance unit hoche meter. So work done unit hobe ki? Force into distance, that is Newton meter, but we do not usually write Newton meter for the unit of work done. Exactly, we write joule. Exactly. So that's the point that I'm trying to make. That, but at what is pretty important, that sub graph, but every graph's gradient would not be a defined quantity. Similarly, every graph's area under the graph would not be defined quantity. It is dependable based upon what quantity do you know, or what quantity do you deal with. For example, area under the force versus distance graph can give you work done. But can you tell me what should be the what quantity, what physics quantity should the gradient of this graph represent? If we go for gradient calculation, which should be del F by del D, okay, should have a unit of what? Newton per meter. What unit does this, which quantity has this unit? Can you think of a quantity that has this unit? Please think. Newton per meter.
Is it the one that is applied in extension? Calculate extension, maybe.
That's actually good. Yes. For the Hooke's law, spring constant, exactly. For the Hooke's, if you go for F equals to kx, where x is the extension of a body and F is the applied force, K can have a unit of Newton per meter. That's actually genius. I was not thinking about this. Yes, true. Beautiful. So, but as you can see, there is a limitation for this formula to be used. This is applicable for deformation cases, right? This is exclusively applicable for what? Deformation cases. But in this example that I described, the way I described this problem, this was not the case of deformation. We are applying force to an object which was going in a straight line forward. But Newton per meter can be a unit of spring constant, which is absolutely correct. But
তাহলে ফর্মুলাটা কি অ্যাকচুয়াল ফর্মুলাটা কি তাহলে?
কিসের অ্যাকচুয়াল ফর্মুলাটা?
মানে কে এর মানে স্প্রিং এর কে এরটা, হ্যাঁ।
You subject K out of this equation, what do you get? If you subject K from this equation, what should you be? What should be there on the right side?
N new x. Sorry, I mean x.
No. If you subject K on the left side from this equation, what should be on the right side?
Fx. K equals to fx.
No.
Is it
F by x.
F by x.
Oh.
ঠিক আছে?
K is equals to F by x.
বুঝা যাচ্ছে?
Yes, sir.
So if you subject K from this equation, you get K equals to F by x. So that can be the equational expression for spring constant, which works for us. But that is not the same case that I had discovered in this on the left red and green graph. So although Newton per meter can be a unit for spring constant, for which you are absolutely correct, but you cannot apply that constant for a situation where an object was actually moved. For this case, there was no indication of a deformation. So you cannot say logically, you cannot say. Mathematically, it's similar, but logically you cannot say that the gradient of force versus distance graph should be spring constant, because the whole idea of spring is not applicable here. Do I make sense? If this was in an extension scenario where there was some spring which we did make some extension, we could say that this was force versus distance gives us, or force versus extension gives us the spring constant, but that is not the scenario over here. So even though if the if the units do match, you need to use your understanding of physics to decide, is it applicable for this scenario? Ask me questions if you have any. It's important that you appreciate this idea. Anyone? No one? Okay.
স্যার আমি বুঝিনি, আবার একটু বলবেন।
কোন পার্টটা বুঝো নাই?
আপনি মাত্র যেটা বললেন।
কোন জায়গা থেকে? মাত্র তো অনেক কিছু বলতেছি।
আপনি মাত্র যেটা বললেন যে ডু ইউ অ্যাপ্রিশিয়েট দ্য ফ্যাক্ট, আপনার কথা কেটে কেটে আসছিল।
ওকে, ডু ইউ অ্যাপ্রিশিয়েট দ্য ফ্যাক্ট?
এর আগে।
কতটুকু আগে থেকে?
আচ্ছা আমি ইউটিউবে দেখে নেব না।
Beautiful. You see, when you ask this question, you have to specify, স্যার আমি এইটুকু পর্যন্ত বুঝছি, এর পরের টুকু থেকে বলেন। If you ask me, স্যার একটু আগে থেকে বলেন, and what do you mean by একটু আগে? I understand that you missed up some part, but I have no indication or not to what you are asking exactly. বুঝছো কি বলছে? It's not that I don't want to answer your question, but your answer needs to be specified. Your question needs to be specified, okay? আচ্ছা সমস্যা নাই, ইউটিউব থেকে দেখো, না বুঝলে আমাকে আবার মেসেঞ্জারে মেসেজ করে নক করো, I'll help you to understand, no big deal. আচ্ছা, so this was the important bit. So আমাদের সব গ্রাফে, so the point that I'm trying to make is that আমাদের সব গ্রাফেরই গ্রেডিয়েন্টও থাকবে না, বা গ্রেডিয়েন্ট ক্যালকুলেট তুমি করতে পারবা, গ্রাফ থেকে ক্যালকুলেট করার সমস্যা না, but we cannot essentially define the gradient of every graph by some physics quantity. Similarly, all the areas cannot be specific quantity. So if I go ahead and write some very simple graph, let's say if we have a dt graph, what is the gradient of this graph? dt graph, distance over time. What would be the quantity represented by the gradient of this graph? Speed or velocity, right? It can be speed or velocity.
Yes, speed or velocity.
What would be the area under this graph? If you multiply distance with time, what you're gonna get? What would be the area of this graph?
Speed.
No. Area. Area means you are multiplying d with t. আচ্ছা, আমি এরিয়া ক্যালকুলেশন আরেকটা পার্ট অ্যাকচুয়ালি বলতে ভুলে গেছিলাম। For over here I showed you the calculation for trapezium, that there are three different shapes that we usually work with for whenever we're calculating area. For a triangle, the area is given by half into base into height, right? So base essentially means the x-axis variable, and height usually represents what? The y-axis variable. So this h represents the y-axis variable. Half is the numerical constant, so that basically doesn't matter. So you're also multiplying the two variables. The other shape that you can work in many cases is the rectangle. So for what do we multiply for the rectangle? Base into height. So no matter where you are trying to calculate the area of a certain geometric shape, you're always multiplying y-axis variable with x-axis variable. That is a given. There might be some addition, subtraction, there might be some constants involved, for example half, but ultimately that is the general process. So that was that. So I'll rescue you from this question. What I asked, that what should be the area of this graph represent? The answer to this question is nothing, because d multiplied by t does not give us any defined physics quantity. However, if I have a graph of vt graph, what is the gradient quantity of this graph?
Acceleration.
Hear me out. What is the gradient quantity? Gradient quantity of this graph. That is acceleration. Gradient quantity. Someone said distance. Distance is the area quantity. So a graph distance. So for this graph, the gradient also means something. The area also means something. But that's not the case for here. For this graph, a meaningful quantity was only the gradient. The area of this graph did not mean any meaningful quantity. But for this one, both of them are available. Similarly, if I go ahead and draw a graph of, let's say, acceleration versus time. Acceleration versus time. Have a look. Acceleration versus time is not very highlighted in your syllabus, but I prefer to teach this because this is an inclusive part of the whole discussion. So if you have a graph of acceleration versus time, what would be the gradient of this graph, and what would be the what quantity should be the gradient of this graph, and what quantity should be the area of this graph?
Gradient velocity.
This should give you a unit of meter per second squared divided by second. which should eventually translate into meter per second cube. Think about it. This is on the denominator, right? So if you take it up, it should be h to the power minus 1. Make sense?
We have a graph like acceleration and time.
You can. It's not essentially highlighted in your syllabus, but we can always plot it if you want. I'm trying to give you the idea over here that the gradient of acceleration versus time, the quantity of the gradient of acceleration versus time can be meter per second cube. But this is not defined as any practical physics quantity. So the gradient of this graph will not give you any useful information. You can calculate that, but that's not any physics quantity that is. Do I make sense? Gradient of
Yes, sir.
acceleration time graph would not give us any
Yes, sir.
useful physics quantity. What about the area of acceleration time graph? If you calculate the area, so I need you to think in your head, A multiplied by T can give you what?
Velocity.
The units would imply that. Have a look. The
Acceleration.
area A is already acceleration. So if you multiply by T, you do not have acceleration. You should get something else. The unit of acceleration is what? Meter per second squared. The unit of time is second. Yes. If you multiply, then you get meter per second. So this might be a very good indication that acceleration with multiplied by time gives us velocity. But it is not entirely correct. I'll tell you why. Acceleration is not only v by t. Acceleration is usually del v by t. Remember this equation? Acceleration is not v by t. Acceleration is usually change of velocity over time. Do you know this equation? Have a look.
Yes, sir.
This is the correct equation. Acceleration equals to v by t. You have never seen that. So if I do the cross multiplication over here, you get what? Delta v equals to a into t. So acceleration multiplied by time does not give you velocity exactly. It gives you change of velocity. That's the important bit. The unit is same. Velocity into meter per second, change of velocity into here, meter per second. So acceleration versus the area of the acceleration time graph gives you change of velocity, not exactly velocity. This is something that is important for your MCQ questions. এই টাইপের কোশ্চেন, এই টাইপের মানে ছোট ছোট মানে অ্যাসপেক্ট গুলি typically examiner CIE people, they tend to set this up in the MCQ questions. So if you have a good concept, if you have a good hold of concept, you can instantaneously answer these questions. But if you don't know this concept, you will struggle. বুঝতে পারতেছি?
Yes, sir.
So এরকম আরো অনেক different graph আঁকা possible. Different graph আঁকা possible কিরকম আমি কিছু example তোমাদেরকে দেখাই. First, let's say if I draw a graph of mass versus volume, what would be the gradient of this graph? Mass versus volume.
Density.
Beautiful. If you plot a graph of force versus area, what should be the gradient of this graph?
Pressure.
Then again, if you plot a graph of pressure versus area, what should be the gradient of this graph?
Force.
No. You need to listen. I'll say it again. If you plot a graph of pressure versus area, what should be the gradient of this graph? Nothing. If you calculate the area of the pressure versus area graph, if you P into A, P multiplied by A, that gives you force. So you have to think that gradient means division and area means what? Product. Multiplication. So over here, the gradient gives you pressure, but the area doesn't give you anything. Over here, the gradient doesn't give you anything, but the area gives you force. বুঝা আছে কি বলতেছি?
Yes, sir.
Yes, sir.
You have to be careful to look at the word. That is the question asking about gradient. Gradient would mean division of the two quantities and going forward. Area would mean multiplication of those two quantities. So you have to be careful about the term that you are working with. Just question পড়লাম ধমাধম answer করে দিলাম, that's not essentially a very good practice, or in most cases you will be wrong if you go that. Don't rush your process. Take your time. You are learning, take time. বলো।
So আপনি যে একটু আগে যে a equals to velocity divided by time, এটা কি আর কোনো ফর্মুলা টাইপের নাকি? এই ফর্মুলা নাকি অ্যাক্সিলারেশনে?
এটা?
হ্যাঁ।
হ্যাঁ এটা অ্যাক্সেলারেশনের ফর্মুলা। চেঞ্জ অফ
তো
ভেলোসিটি
আপনি আবার ডেরাইভেশন কিসের জন্য আবার কেন ডেরাইভেশনের মানে দরকারটা কি ছিল? আপনি যে ভেলোসিটি ডিভাইডেড বাই সামথিং ইকুয়ালস টু a বাই t, এটা মানে কিসের জন্য? মানে যদি মানে বলেন কারণ অ্যাক্সেলারেশন আর টাইম দেওয়া ছিল কিন্তু ভেলোসিটি দেওয়া ছিল না, তাহলে কি এটার জন্য ফর্মুলা? স্যার
আমি তো কোশ্চেন শুনছি, চিন্তা করতেছি, ওয়েট। This is the formula this is the definitive formula for acceleration. I wrote this formula to give you a glimpse that product of acceleration and time would not be only velocity. There will be a delta involved. So you cannot say that the area under the acceleration time graph is velocity. That would not be entirely correct.
Yes.
Area under the acceleration versus time graph would be change of velocity. That's what I was trying to highlight.
Yes.
So what was your question?
No, this was the question, that why for what you gave this formula, for it,
okay,
was
right.
It something necessary if you
Yes,
use
it
this
was necessary
formula?
to bring about that idea, that change of velocity, not only velocity. Writing only velocity would be somewhat wrong.
Okay.
So এরকম আর অনেক কিছু হইতে পারে, তোমরা অনেক different quantity নিয়ে পড়বা, and a lot of different quantities will be taught to you in the upcoming classes as we slowly go ahead over this entire course of the syllabus. But in all cases, we can draw multiple graphs of multiple variables, and you need to think in your head that if we divide these two variables, do we get any useful information? If we multiply these two variables, do we get any useful information? And based upon those information, we can do a lot of manipulation or data out of that thing. But it's not always important. It's not always true that all both gradient and area might give you some useful information. That's not essentially true. In some cases it might, in some cases it might not. That's the example that I was trying to get in your head by showing you all of these graphs. বুঝা গেছে?
Ji sir.
Everyone?
Yes sir.
Achha. So this is pretty much 7:30. We'll close the class in a bit. From our next class, we'll start the second chapter of your syllabus, which is force, acceleration, motion. The first chapter happens to be physical quantities and measurement. Quantities and measurement is a pretty small chapter. I usually tend to work with this one after the second chapter. I prefer to teach the second chapter first, which is the motion things and distance, displacement, velocity, speed, acceleration, equations of motion, graphs, reaction time, habijabi, এগুলো যে চ্যাপ্টারটাতে আছে, the whole thing that is in physics term, which what we cover in kinematics and dynamics. We'll start that chapter from next class onwards. Thank you very much for your patience, everyone.
The next class is on Friday.
The next class is on Friday, yes. আচ্ছা, Friday class নিয়ে একটা জিনিস আমি তোমাদেরকে আলাপ করছিলাম, সেটা হচ্ছে one of our parents asked us that if it's not inconvenient for all of us, could we possibly shift the class half an hour late. So is it possible that if we can make this class 5 to 7:30? That would be convenient for some of our students. One of our students actually personally messaged me that, sir, please talk about this. It's also convenient for me as well. So I don't have much time to take all of your votes over here. I really don't want to get into discussion, but I'll talk to you kids about it in the messenger group. Don't start putting down all of your problems. I mean, if you do not have any problem from 5:30 to 7:30, then just keep it quiet. I will take it as yes. But for those of you who cannot make it, I mean, cannot make it means that you have some other overlapping classes. That's what I mean. Not that I'm gonna take a nap at 3:30, so I have to sleep up to 5:30, or I have to sleep up to 5. So don't make reasons like that. Someone is having some collision, that's why they preferred this time frame. So think about this and do some responses. If you have any collision, if you don't have any collision, keep quiet. Don't mess up the message. Don't get some message. Thank you very much, kids. I'll close the class and see you all on Friday.
Assalamu alaikum, sir.
Bye bye, sir.
Assalamu alaikum.
Assalamu alaikum, sir.
Thank you.